We are the team realizing the auditorium, part of this great and impressive project. This part is a wooden structure consisting of stunning organic forms, so to speak a sculpture-like jewelry box. Apart from the difficulty of its form, this part of the project is in itself a structure that needs to be technically resolved so as to host conferences as well as instrumental performances. When we were first introduced to this project, there was uncertainty as to the production technique that could be used to realize this amazing wooden form. While exploring the ways in which we could realize this production, we divided the matter into 3 stages. 1. What the frame structure had to be like to exactly meet the Zaha design team requirements. 2. How the surface would be formed over this reference frame. 3. How the acoustic and other technical requirements of the multi-purpose use of the space would be met with the chosen production techniques. We first had to decide how we could build up the form. Since the surface was 3-dimensional and was constituted of non-repeating surfaces, we couldn't make a mold. Each surface was to be produced only once. And although the form appeared to be sculpture-like, it had to exactly match the digital model approved by the Zaha team. This required that it be produced based on these references. It wasn't just a craftsmanship job. We considered several techniques. Some of these we tried. 1. The surface could be made of solid wood pieces which could be shaped with a 5-axle CNC router. Acoustic simulations required that material thickness be uniformly about 45 mm. It was going to be quite difficult to achieve this by bringing solid wood pieces together, and a CNC router that could handle such large pieces didn't seem very efficient. 2. The carcass beneath the surfaces could be formed using various materials such as metal or wood, covered with plaster, fiberglass or stretchable fabric with a final layer of wood. 3. We also tried to give shape to polystyrene material with a CNC router, strengthening it with fiberglass and covering it with wood. We couldn't exactly achieve the results we desired with any of these techniques. We realized that exact coordinate descriptions had to be made for the carcass, and that the covered surface had to lengthen and shorten in a defined way at very close intervals at each section. Also, we had to avoid undesirable wood grain patterns on the surface. We developed a new method to achieve the desired wooden forms. We first prepare a 3-dimensional frame model with a reduced surface cover thickness that is completely consistent with the desired skin. We then convert the thousands of different vertical and horizontal pieces to a format which can be produced with a CNC router. At the end of the process, when these surfaces come together, they exactly constitute the form we desire. And then with a method that can be considered craftsmanship, the surfaces are constituted by gluing and nailing wooden strips which have been prepared at dimensions which permit the curves to be shaped. The surfaces are covered again and again 4 times, buffing and correcting the surface at each layer until the desired thickness is reached. We call this production method engineered craftsmanship. Except for the stage and back walls, the auditorium is formed of wide wave-like rings. We produce each ring in 3 stations, 1 top and 2 sides. Although each station, depending on its size, consists of 8 to 15 pieces, the seams are planned and the stations are produced as if they were built in as a whole. Then the end sides of the stations are brought together by joining ceiling and wall elements, and minor adjustments are made while controlling the junctions. Therefore, the entire assembly of the ring is simulated here. For this, the whole system and measurements are done in accordance with 3D Rhino models. Otherwise, discontinuous pieces that look as if they were only one piece may end up at entirely different measures. Therefore, measurement differences and divergences that may arise during the installation and covering of the frame are totally prevented. All measurements are constantly matched with the 3D digital model. Otherwise, it would be impossible to bring together pieces with three-dimensional junctions. This sculpture-like space is in fact produced to equal the final form approved by the architect. Also, when these pieces reach the site, they must fit the planned points exactly, otherwise when assembled continuous pieces of the size that couldn't be fitted on site couldn't be installed in a space where internal gaps can be almost 5 to 6 centimeters. While planning the production, we need to overcome constraints resulting from technical requirements relating to production techniques, architectural design, acoustics, sound and stage systems, fire, lighting, etc. Some issues, which need revision and mutual approval, have to be solved at the beginning, during the production modeling stage. For instance, some coverings have no space to hang on the main structure. Some diameters are too sharp for the production method. The angles that are needed for the speakers to face the audience have to be coordinated with the general form, etc. During this stage, all these solutions and sections need to first be simulated on the 3D model, and their compliance with the job needs to be approved first by all disciplines and then by the Zaha design team. We must produce the exact form approved by the architect. We cannot produce an approximate form. Finally, we produce this approved model. The Zaha team is extremely keen on details. Therefore, there is no margin for error. In this project, apart from our contracting role, the task of acoustics and coordination for the auditorium is also ours. Therefore, when we initiated the project, we started collaborating with Professor Mehmet Çalışkan from Middle East Technical University and Mezzo Acoustic Consultancy. According to the utilization needs of this auditorium, a technical solution was needed, adaptable to the structure where both conference and instrumental performances would take place. While performing acoustic simulations and calculations, the consultants offered the solution of coupled room. The volume inside can be increased and decreased thanks to various panels which can be opened and closed. We developed a system solved with the necessary meticulousness that would get the architect's approval of 12 flaps which could be completely opened and closed on the ceiling of the front ring. The closable panels have to mold with the wave-like form of the ceiling and open and close simultaneously. This requires very precise calculations and careful workmanship. Also, our design and production teams had to brainstorm and cooperate extensively to be able to produce exactly as desired the slots on the concave surfaces on both sides of the auditorium that were needed to meet architectural and acoustical requirements. What was done here is a very intensive job in terms of design, engineering, craftsmanship and workmanship. Meanwhile, we completed the acoustic layers and the catwalks in the auditorium. While the acoustic layers were being made, the vibrations, therefore the sounds that would be carried between the wooden surfaces that were being formed inside, the load-bearing walls outside and the steel ceiling beams had to be insulated. For this reason, we created a second steel frame fitted on the ceiling with rubber pads. We also installed on the ceiling and walls, again using rubber pads, the connection points that would hold the wooden structure and the multi-layered sound insulation walls. Between the outer walls and the wooden structure, using these connection points, we built multi-layered intermediary sound insulating walls to insulate sounds that might travel from outside to inside and vice versa. It was now time for the visible side of the job, the assembly of the woodwork that had been produced in our factory. As the project progresses, we realize how much we have learned by being part of it. We can say that all our team is both very enthusiastic and proud of being part of and working on such a project.